Hello everyone. For this presentation, we're going to go over some of the ways that we are able to classify the joints, and this will help you with the lab assignments. First, we're going to start with the classification of the joint based on the shape. First, we have the hinge joint, which, like the name says, it's going to be a synovial joint that's going to resemble the shape and movement of a door hinge. And it has a cylindrical surface on one bone that fits into this concave surface on this adjoining bone. And this structure will allow for movement primarily in one plane. So it's going to be similar to the opening and closing of a door, where the flexion, which is the bending, and the extension, which is the straightening, being the primary motions. And examples of hinge joints are going to include the elbow and the knee joint, and we're going to talk more about them coming up. Next, we're going to have the pivot joint, which is also a type of synovial joint where one bone has this rounded or cylindrical surface that fits into a ring or sleeve that's formed by another bone, and it's going to be reinforced by ligaments. And this unique structure allows rotational movement around a single axis. And this will enable one bone to rotate around the other. And this is much like a wheel that's turning on its axle. Now, these ligaments in this joint are going to be essential for stabilizing it, ensuring that there's a smooth, controlled rotation, while also preventing an excessive or even unwanted movement. An example of a pivot joint is the atlantoaxial joint, which we will see coming up later on. Moving on, we have what we call the condyloid joint, which can also be called the ellipsoidal joint. And this joint, it's going to feature an oval-shaped articular surface on one bone that will fit into this complementary oval-shaped depression on another bone. Next, we have what we call the saddle joint, which is going to be a type also of synovial joints, where both articulating bone surfaces are going to have a concave and a convex shape resembling a saddle. As we can see from this image, the surfaces will fit together like a rider sitting on a saddle. And this is why it's called a saddle joint. Now, both the ellipsoid and condylar or the saddle joints, they will allow the movement in two planes. Therefore, flexion and extension in one plane and abduction and adduction in another plane. It also sometimes permits this limited circumduction movement, but it's not a full rotation, which will distinguish these two from the ball and socket joints, which we will see next. An example of the condylar joint is the wrist joint, and an example of the saddle joint is going to be the metacarpal joint of the thumb, and we will talk more about this coming up. Now next, we have the ball and socket joint, which is going to be again a synovial joint, where there's going to be this spherical or rounded head located in one bone, which looks really like a ball, and it will fit into this cup-like or concave socket of another bone. And this shape will allow for the widest range of movement of any joint type, including movement in multiple planes. So besides flexion and extension and abduction and adduction, which we have seen on the previous ones, we're going to have rotation and circumduction as well, which is the circular movement. Examples of ball and socket joints, we have two, which are the shoulder joint and the hip joint. Now these joints, they will allow this extensive mobility, such as, for example, swinging the arm or the leg in various directions. Lastly, we have what we call the plane joint, which can also be called a gliding joint. And this is going to be a type of synovial joint where the articulating surfaces of the bones are going to be flat or basically nearly flat, and this will allow them to glide or slide over one another. Now, as you can imagine, The shape of the joint will restrict the movement to very small gliding motions that can be either on one or more axes, up to 3 axes, without having rotation or any significant bending. So it's just a gliding or a sliding of one bone against the other. A typical example of a plane joint or a gliding joint will include the joint between the carpal bones, or we can say it an intercarpal joint located in the wrist. So this summarizes all the different types of joints based on the shape. Now let's look at the type of joint based on the motion. So we did talk a little bit about motion on the previous slide, and there are basically 3 different types of motions. And this classification will help us understand how different joints can contribute to the body's overall flexibility and mobility. First, we have what we call a monoaxial joint, also known as uniaxial joint, and these joints will allow movement in only one direction or axis. An example is going to be a hinge joint, like the elbow, which only permits bending and straightening, and also a pivot joint, which allows rotation from one side to the other. So basically, it's just going back and forth, either at the hinge joint, opening and closing, or flexing and extending. And on the pivot joint, it's also in one axis, so it goes from side to side. And we will cover them in more details when we talk about the specific joints. Next, we have what we call the biaxial joint. And these joints, like the name says, will allow the movement in 2 different directions or axes. So for example, the condyloid joint will permit the bending and side-to-side movement, which will be the flexion and extension, or abduction and adduction. And an example of this is going to be the condyloid joint and the saddle joint. Lastly, we have what we call the triaxial joint. And these joints will allow the movement in 3 different directions or axes. And this will provide, like I said, most range of motion. And we have 2 examples, the ball and socket joint, like the shoulder and the hip joints, which will allow rotation, bending, and lateral movements. And then we also have the plane or gliding joints, where the bones will slide against each other in up to 3 different planes. Now we're going to see the different types of movement of all of these synovial joints. And here is a list of them all, and we're going to talk about them in the upcoming slides. But for most part, one thing that you can think about in terms of movement is that there's always going to be a back and forth movement in that same plane. So if you have a flexion, you're going to have an extension, which is moving in the same plane. If you have abduction, you're going to have adduction, also moving in the same plane. Pronation and supination is a back and forth movement. Elevation and depression as well, and so forth. So keep this in mind once we get to the different types of movements. Here we have an example of flexion and extension, and sometimes we can have a hyperextension depending on the type of joint. On our first example here to the left, we have flexion and extension at the shoulder. Now once you bring your arm up from an anatomical position, you're going to be decreasing the angle at the shoulder. Therefore, this will cause flexion at the shoulder. Once you bring the arm back down into anatomical position beside your hip, this will be extension. And if you move your arm further back, this will cause what we call hyperextension. Same thing for the hip joint, which is the images here to the far right. So when you bring your thigh up from anatomical position anteriorly, this will be flexion. When you place it back down, back into anatomical position, this will be extension at the hip joint. However, if you swing your thigh further back, this will represent hyperextension. And in the middle, we have movement that's occurring at the knee. And at the knee, we don't have hyperextension, because if you were to bring your knee past the joint, this will break your knee, right? So therefore, when you're bending your knee posteriorly, this will be flexion, and when you bring it back into anatomical position, this will be extension. So there is no hyperextension on the knee. Here we have examples of adduction and abduction, not only at the shoulder joint, but also at the hip joint. So our arms, when they are in an anatomical position, once you bring them up and move it sideways in the coronal plane, this means that you're taking the arm further away from the midline. So this will cause abduction. Like when you take a person away, you're abducting that person. Same thing occurring here at the arm. When you bring it back to the body, will be adduction, because you're adding it to the body again. So ADD, adding to the body. Same thing on the hip. If you're moving your thigh further away in the coronal plane, this will be abduction, ABD. And when you bring it back, you're adding it to the body, this will be adduction, ADD. And on the image to the right is the same thing. I just wanted to put this image here because when we're talking about adduction, we're actually talking about bringing the body part back into anatomical position. So see how these lower limbs are straight? So this is actually the adduction. It doesn't necessarily cross over like we see here on this image for the lower limb, or like we see on this other image for the upper limb. Now we're going to cover pronation and supination, which will refer to this rotational movement of the forearm and the hand. In the forearm, pronation is going to be the motion that will turn the palm downward so that the radius crosses over the ulna, as we can see right over here. And in this position, the thumb will point inward toward the body. Therefore, in the forearm, supination is going to be the opposite motion, where the palm is going to turn upward and forward with the radius and the ulna lying parallel, therefore going back to anatomical position. Here we have elevation and depression, which describe the movements that occur in an upward or downward direction, especially in the shoulder and the mandible. So elevation of the shoulder will refer to the lifting the shoulder upward, as in shrugging your shoulders or raising them toward your ears. Depression of the shoulder is going to be the opposite movement, where the shoulder is going to move downward, therefore lowering the shoulders away from the ears. Here for the mandible, we have the elevation of the mandible, so this will involve raising the lower jaw or the mandible upward, such as when closing the mouth or clenching the teeth. And depression is going to be the opposite, so it will refer to the lowering of the mandible, as in when you're opening the mouth. Here we have medial and lateral rotation at the hip, where medial rotation involves rotating the thigh inward toward the midline of the body, and lateral rotation is going to be the opposite, where the thigh rotates outward away from the midline. Of course, these movements occur, like I said, at the hip, and this will allow the leg to turn in and out, as we can see here on this image. Here we're going to focus on the torso movements, which are going to refer to the various ways that the torso can bend and rotate. Let's start with the flexion, where this movement involves bending the torso forward, therefore decreasing the angle between the torso and the legs. As we can see here on this image, where if you want to touch your toes, you need to have flexion occurring at the torso. Next, we have lateral flexion, and this will refer to the bending the torso sideways, and it's going to be away from the midline of the body, as we can see on this image. Therefore, you're leaning your torso to the right or to the left to reach something on the side, for example. Next, we have hyperflexion, and this is going to be an extreme form of extension that occurs when the torso bends beyond its normal range of motion. And often this actually causes a discomfort or injury, so you have to be careful when doing this. Make sure that you're warmed up, your muscles are warm, and that you do it slowly. Lastly, we have the rotation, which is this movement that involves turning the torso around in its vertical axis. So, for example, you're twisting your upper body to look behind you in a rotational movement, like we can see on this image. And this can occur actually in both directions. Here, we have the rotation occurring to the left side, but the rotation can also occur to the right side. Now, these movements are going to be essential for various activities that will include bending, twisting, and reaching, and they will contribute to the overall flexibility and mobility of the torso. Here we have what we call protraction and retraction, which refers to the movements that occur in a forward or backward direction. Let's talk first about protraction of the shoulder, where in this movement it will involve moving the shoulder blades or the scapula forward and away from the spine, so in the anterior direction, such as when you're reaching forward or pushing something away. And the opposite will be the retraction of the shoulder, where the shoulder blades are going to be pulled backward toward the spine, so back into anatomical position. We can also have protraction and retraction of the neck, so this will involve the same type of movement, but now with the head. So you're going to move the head forward, as we can see here from this image, and the retraction is when you're bringing your head back into anatomical position. And lastly, we have protraction and retraction of the mandible. So when you're protracting your mandible, you're moving your mandible forward, like when you're pushing your jaw out, as we can see here on this image. And retraction just means that you're moving the mandible backwards back into the resting position. Plantar flexion and dorsiflexion are going to be movements that only occur at the ankle joint and therefore will involve the foot, where plantar flexion involves pointing the toes downward like a ballerina, and dorsiflexion is going to be the opposite movement, where the toes are going to be pulled upward towards the shin, as we can clearly see on this image. Inversion and eversion occur at the foot. Therefore, eversion is going to be a motion of the foot that will turn the sole outward, as we can see over here. And inversion is going to be the opposite movement, turning the sole inward. Notice how it's not going back into anatomical position. So either you're pushing your foot outward for eversion from the midline, or you're pushing your foot inward for inversion away from the midline. Here we have what we call circumduction or rotation of the shoulder. Let's first define circumduction, which is going to be this movement that involves a circular motion of the shoulder joint, and it's going to combine flexion, extension, abduction, and adduction. Therefore, during circumduction, the arm is going to move in this circular pattern, creating this sort of cone-like shape, as we can see being depicted here on this image. Now, shoulder rotation is a totally different movement, but this will refer to turning of the shoulder joint around its axis. And there are going to be two different types of rotation. You can either have an internal rotation or an external rotation. An internal rotation is like the image is showing here. So this will involve rotating the arm towards the body. so that the shoulder joint moves inward. And the external rotation is going to be the opposite movement, where the arm will rotate away from the body. Lastly, we have what we call opposition and reposition, which is going to be a specific movement of the thumb that will permit it to interact effectively with the fingers. Therefore, opposition involves a movement that will bring the tip of the thumb across the palm to touch the tips of one or more fingers. And it allows, for example, grasping or pinching action, which of course is going to be essential for many of our daily tasks, like holding objects, for example. In fact, it is a unique movement that differentiates humans from many other species. Now, the reposition is going to be the reverse movement of opposition, where the thumb moves back to its anatomical position, away from the fingers. And together, opposition and reposition are vital for fine motor skills and also the functional use of the hand. There will be a separate presentation where I will cover specific movements at specific joints.